Hello guys, in the continuation of yesterday's topic on the Redshift, today I'm going to cover a new topic for Redshift. So yesterday I've just covered the high-level architecture of Redshift, leader node and compute nodes. So as you understand in the previous video, that Redshift is a massively parallel processing data warehouse which is hosted on AWS. And whenever there is a query hit by the user to the Redshift, Redshift first analyze the query, create the optimization plan, and then create multiple subtasks, and then it sends every subtask to different compute nodes. The compute nodes execute the task in parallel, and then finally they return to reader node, and reader node then get back to user. And today we'll be covering a very important topic, which is a very favorite topic in the Redshift interviews. And if you want to work in the Redshift also, this concept should be very clear. So the concept is distribution key. So as you understand, when Redshift distribute the data in a different node in parallel to get faster executions, there should be some distribution strategy, and Redshift support the distribution strategy using distribution key. So for explaining it in a simpler manner, I just created this diagram for all of you. If you can see in the left hand side, you can think this is a table, which is a very simple table. It's an employee table which is having employee IDs, department IDs, corresponding department IDs where employees are working, and corresponding salary for the employees. Now, the requirement for the query is you have to write a SQL query where you want to find the average salary for each department. So if that is the case, if you can see the right hand side, this is the Redshift architecture where the query will be executed. So I can write a query in such a manner, right? And before doing that, I can create the employee table in such a manner that it will basically distribute the data so that the query will run faster. So for that, you can see that we have around six departments as an example, and we have six compute nodes. And for each compute nodes, I have distributed the department data. Each department corresponding employee data will go to the one node, right? So for doing that, I have to just say Redshift that I am using a distribution strategy called key. And for the distribution key, I'll be using department ID. So the moment I tell that, the leader node will understand that, and it will basically create the employee table by creating or distributing the total data using department ID data for each node. Now coming next, there are four key distribution styles available in Redshift. So if you are starting a work in Redshift or you're already working in Redshift, if you have to do the query optimization, these are very necessary concept. Key one I've already discussed with you. There are others are there. That's all, even, and auto. You will see what are the advantages of those. Now, this style key, this is just a revise. If you can remember the architecture which I was showing the diagram, this is the employee table. We have employee ID, department ID, and salary, right? And there I will mention this key as department ID. So that does mean the moment I mention that, whenever the data will be inserted, what Redshift will do, it will basically distribute the whole data using department ID data. So for each department ID, corresponding employees will go to the single node, and then everyone will execute parallelly. So for each department, the average salary calculation will happen in every node in parallel. They will finish in parallel, and then they will get back to the leader node very quickly so that we can get the average salary for each employee. So this is the example I've just given to you whenever you are calculating. So this is the key-wise distribution of the Redshift. Now, this is just a two, three observations that rows are distributed based on the values in distribution key column. So distribution key value uh, will be basically driving the distribution of the data. And this is particularly useful when you have a large tables, right, with on the same key. Like the example we have given, we have a employees table, or we may have a lot of sales data, right, for geography wise, and you can use geography as a key, right? Asia, then Europe, then US, then Latin America, like those kind of large tables where you have a lot of data you want to distribute on the key. This type of distribution style will be better. Now, even is a very simple thing. Even is basically round robin fashion. So if you can see here, I said the distribution style even. The moment I said even means if I have a four node, so what it will do, the Redshift will start distributing the data in an even manner. So it will first give the data to node one, then node two, node three, node four. Now, to understand this, is like whenever we are playing cards, right? And we, if four people are playing cards, so when we distribute the card, we give one card to each one, right? So you have 52 deck of cards, so one card for each one. So you can think that as similar to the even distribution type of Redshift. Now, as I told you, the here rows are distributed evenly across the all nodes. With regard to the any particular column, right? I mean that doesn't mean, I mean it will just share the data evenly, and this is good for optimization for smaller table where there is no natural key, or I mean no natural key to optimize the query performance, right? If it's a small table, you want to go for a even, then fine, because there is no key which basically give you advantage over the key distributions or all distributions. So that is better to go for an even distribution. Now, this style all is a very important concept. It is a very simple concept also. If anybody who have worked on Spark before, you have heard about the broadcast join. So it is similar to that. So if you can see, I have just created two tables. One is a create table department, another is the employees table. So employees table have employee ID, department ID, and salary. Whereas department table have a department ID and name. And there is a requirement that I want to just know the average salary for each employee, and for that I also want to showcase what is the department name of that average salary, whatever I'm calculating. So if that is the case, I have to join these two tables, right? I have to join this table because this table don't have department name, so I'll get it from this table. So what I can do, this table I've already discussed. You can create using department ID or Distkey, that is already discussed. But this one you can say this style all. So what does that mean? So that does mean the department data, which is a master data, which is a smaller table, it will basically go to every compute nodes, right? So that will basically make the join easier. If you can see here, I've just draw the diagram. So basically, if you can see, these are the compute nodes, and for each node, you can see the department data set have arrived. Now, there are some advantages and disadvantages. The advantages is that it will basically reduce your shuffling, right? So because your data is already available locally, so the join will be very fast. But the problem is it will copy the data multiple times. So if you can see, there are six nodes, compute nodes, and the data is copied six times, right? So that is little bit costly. So we don't prefer this kind of joins if the table is not very small, right? So the last one is a this style auto, which is by default Amazon gives you. So if you do not define anything, then Redshift automatically assign an optimal distribution type. And I mean, using automatic selections, it first start with I mean, it will start with the default, and then it will go to event distribution slowly, right? And when you see it change from all to even or any other distribution, it happens in background. So it will not affect the query performance. And you can see the distribution style. Obviously, there is a catalog system table called PG class, right? Where you can see which table actually having which distribution style. But one thing keep in mind, if you just opt for auto distribution style, you do not have any control on the optimization. Redshift to really control that. Obviously, you can alter table and you can change the distribution type later for existing table. But the moment you change that, you cannot request again Redshift to go for the auto distribution, right? From there on, you have to manage it by yourself. Hope you have enjoyed the concept of distribution key, and please like, subscribe to my channel. I will also create more data engineering videos for your benefit. Thank you, guys.